Hi, we are Group 17 with the Dishwasher 5000. Our robots allow a time-efficient way to create a targeted and thorough wash. Today's dishwashing system takes an ample amount of time just to wash the dishes and may still leave residue. Meanwhile, our proposal washes the dishes with powerful jets, scrubs the dishes, and even dries and organizes them for you in less time. This is not only ideal for industrial restaurants, but also the average family and even military bases. Our proposed robots are the Acceptor bot created by Micah Smith, the Jet bot created by myself, Brianna Yoder, the Wash bot created by Bly Doma, and the Dry Organize bot designed by Cynthia Rodriguez.
All right, my name is Micah Smith, and I have designed the first robot in our system. The name of this robot is the Acceptor Bot. Basically, the way that this robot works as an overview is it will accept dishes, it will determine their material, it will communicate with the rest of the system, and then it will send these instructions onto the rest of the robots in the system. So as you can see, there are three bays here on the acceptor bot. There is one for plastic, there's one for wood, and there is one for ceramic. And once the user places dishes in these bays, material sensors will help determine if the correct material has been loaded. If the correct material has been loaded, then the bot will communicate water pressure and soap concentration preferences with the other bots in the system, and then it will use its motorized conveyor belts on the bottom of each bay to move the dishes along to the jet bot, which is the next bot in our system. Last thing here is, as you can see, there are three buttons for user input. It's also easy to see by the flowchart that the green button is what starts the process, so it will open up the bays and allow the user to load the dishes. The yellow button will begin the washing process. Will actually begin to check if the dish is the correct material, and the red button is used to stop the machine if it ever starts running wrong or the user needs to stop the process for any reason.
The JetBot takes the items from the Acceptor bot through the conveyor belt system. The jet spray system will activate as soon as it detects the pressure from the dishes. When the dishes move to the conveyor sensor 1, the dishes will move forward for 10 seconds, pause for 1 minute to be sprayed down, and then move forward for another 10 seconds. Here it will be met by the color sensor where it will detect any remaining stains, and this information will be sent to the second set of jet sprays. Conveyor sensor 2 will come into effect here, move the items along for 10 seconds, pause for 3 minutes this time at the second set of jet sprays, and then move forward for another 10 seconds to the end of the conveyor belt. When the dishes are removed from the wash by the wash bot, the jet spray sensor will no longer detect the pressure from the dishes and the whole system will turn off.
There's going to be two sensors, the light sensor and the distance sensor. For the light sensor, there's going to be one on each side and two at the top. For those sensors and where they are placed, there's going to be a laser on the opposite side. And the reason that those are going to be there is so that if there is dishes and there's no capacity to load any more dishes, all four of those lasers have to show that there's no signal being received from the lasers to signal the motors that it is time to rotate the belt so that more dishes can be loaded. Moving on to the distance sensor. The distance sensor will now be looking out for dishes that are coming from the JetBot. And if there is dishes, the distance sensor will pick it up and it'll be picking it up within a range. If there isn't any more dishes, then the distance sensor will not pick it up. However, there's a failsafe. If the light sensors are at capacity, it will not allow the conveyor belt to roll, and it will also not allow the uh, robotic arms to continue loading dishes.
All right, so now we move on to our dry and organizer bot. Unfortunately, this bot was supposed to be designed by our fourth team member who, due to some personal reasons, needed to drop the class. So as a team, we decided to go back and show our original requirements for this bot, just to give an idea of how it would complete the process for us. So as a group, we came up with these ideas. We decided that the dryer and organizer bot must be able to dry all the dishes and completely kill any harmful bacteria with UV. We said that it must be able to operate at at or below 50 decibels, which is the typical volume level for a home dishwasher. We also said that it's got to be able to handle all dishes delicately regardless of material, as well as store those dishes into a convenient rack for the user at the end.
First and foremost, the placement of each bot will need to be strategic in the sense that the acceptor bot, jet bot, and the wash bot cannot be too far from one another, especially when we are looking at the acceptor and jet bot. Given the jet bot's opening closure, it allows for the acceptor bot to move its conveyor belt from within the main enclosure, reach outside of itself, and allow the jetbot to accept those dishes and realize that there has been pressure coming from the dishes and allowing it to, once it receives that pressure from the dishes that are coming from the acceptor bot and has been giving identification of the different materials and the different dishes that have been read, it'll be able to initiate the cycle. Once the jetbot has reached the targeted spray stage, it will then signal simultaneously the washbot, and the washbot will open its enclosure and be prepared to offload the dishes from the jetbot and into the washbot onto the conveyor belt.
Our benchmarking and value added. Um, so basically, we wanted to compare against three current market solutions. The first that we came up with was the typical washing machine. Obviously, our system is designed to be a much more affordable solution that focuses more on handling each individual dish material type with care. And in addition to this, we also take care of the automatic dish drying and disinfection portion, which we do with that intense UV light. The user may also wish to hire a dishwashing service where they can have somebody come and wash their dishes for them by hand. Obviously, this is a very costly way to go about things, and it could also interfere with the user's privacy because you have to have a cleaner in the home. Obviously, our system is designed to be easy to use, and it removes all of that responsibility without the need to have a cleaner come in and be around the family. And then finally, of course, we've always got classic hand washing. You could slap on a pair of gloves, bust out the soap, and use a little bit of elbow grease, but not everybody wants to get their hands dirty per se. And so our system allows the user to reclaim this time that they would have spent doing dishes with the confidence that their dishes are going to be cleaner than they could be if they washed them by hand, and that there won't be any water wastage in our system. Moving on now to our conclusion, our robotic system is designed to take care of the entire dishwashing process for the user. It's affordable, it's designed to fit easily in the user's home, and it's designed to deliver the same wash quality every single time. The features of our system as an overview include that we can identify the proper handling techniques for a material, and we can communicate that with the other bots in our wash. We also use a color sensor guided pre-wash and water jet accuracy that helps us have an ultra accurate wash every single time. Finally, we also include automatic drying and UV light disinfection, which is something that's not standard in any of the market methods that we discussed earlier. And then at the very end of our system, we decide to go ahead and automatically store the dish in a convenient rack for the user to access in the future. And these are our sources. This concludes the group video presentation for Group 17.